my god!
Okay guys, now I'm going to explain about strengthening mechanism of metal. Strengthening mechanism of metal is a method used to modify the mechanical properties of metal. We use strengthening is to increase the hardness, toughness, ductility, wear resistance and also corrosion resistance of a metal. There are several applications in our daily life. First is construction. Strengthen metals in constructions such as in buildings and bridge. Second is roofing. Roofing is also a type of strengthened metal. Third is heavy duty framing. For example, strengthened metal in heavy duty framing is car body frame and also building frames. These are the type of strengthening we use to improve the mechanical properties of metal. First is solid solution hardening, second is dispersion hardening, edge hardening, strain hardening, strain aging, precipitation hardening, and the last one is grain size reduction. Thank you.
Alright guys, now let's take a look what's grain size reduction all about. Alright guys, now let's take a look what grain size reduction is all about. What is grain size reduction? A process of increasing the grain boundary that acts as a barrier to a slip which increases the hardness of the material. When we look deep into what is grain size reduction, it shows that when the hardness is increased if the slip is decreased, and the slip will decrease if the barrier is increased, and the barrier will increase if the grain boundary is increased. Now let's take a look into what the disadvantages and advantages. Advantages: increase the surface area, uniform flow, and improve the rate of absorption. This is because why? The smaller the particles, the greater the absorption are. And disadvantages are the drop, degradation, and contamination. Now let's look into mechanism of size reduction. There are three types of mechanism: impact, compression, and shear. Impact. Particles are concussion by a single rigid force. For example, hammer. And so on. Compression. Particles disintegration by two rigid force. For example, nutcracker. And shear. Particles against rigid force. For example, a file. That's all for grain size reduction. Thank you.
Okay, now let me explain another two methods on strengthening the metals. Okay, let us go for the method to strengthen the metal. Okay, I will explain another two methods, which is first dispersion hardening and strain hardening. In dispersion hardening, the outline is it can be produced with the help of powder metallurgy, while the full definition is a process where powder of material, shape, size, and distribution are mixed in desired proportion. Here, what we can know is, in dispersion hardening, a powder of material, shape, size, distribution are mixed in desired proportion, we can call as ratio or in certain measurement, so that hardening can be occurred in the method. Next, strain hardening. Strain hardening is a phenomenon which results in increase in the hardness and strength of the metal subjected to plastic deformation at temperature lower than crystallization. Here, in strain hardening, metals are subjected to undergo plastic deformation at temperature which normally will be lower than the crystallization temperature in order to increase hardness and strength. Okay. As you all can see, this is the graph for strain hardening. Okay. Here is first cycle. This is known as second cycle, while the last one is known as strain history. Okay, in first cycle, what will happen is the material is referred to the metal is stretched beyond the elastic range, and the force is removed stretched until to the limit until it wants to fracture. Okay, and the last one is strain history. Strain history is the combination of first cycle and second cycle. Okay, in strain history, there is a final sketch that shows the true strain history of the element. Thank you. Okay, now it's my turn to explain about solid solution hardening. Solid solution hardening is a type of alloying used to improve the strength of a pure material. This solid solution hardening is a process which adding atom to the crystalline lattice of one element to another element to form a solid solution. This process, which is adding atom to the crystalline lattice of one element, is also called as substitutional impurity. The non-uniformity in lattice by adding atom makes plastic deformation difficult by impeding and delaying the dislocation motion. Dislocation motion is divided into two. First is smaller substitutional impurity. Second is larger substitutional impurity. And at last, the metal is hardened by impurity atom which distort the lattice and generate stress which act as a barrier to dislocation motion. Dislocation motion is plastic deformation by plastic shear or slip where one plane of atoms slides over adjacent planes. There are two. First is smaller substitutional impurity. The second is larger substitutional impurity. Smaller substitutional impurity is when the impurity atom is smaller than the host atom. So here will produce the compressed stress. When we look into the largest substitutional impurity, the impurity atom is larger than the host atom. Okay, so this will produce the tensile stress.
चाहे तुम कुछ ना कहो, मैंने सुन लिया के साथी प्यार का मुझे चुन लिया, मैंने सुन लिया.
I'm sorry, I accidentally.
It's okay. I was thinking on something else.
Is everything okay? You need me to help?
No, it's just I was thinking about. Can I have a look?
Yeah. Oh, age hardening.
You know about it?
Yeah, I know about it.
Oh,
Come, let me
okay.
explain.
Yeah.
Alright, so now let's look at edge hardening. What is edge hardening? Edge hardening is a form of strengthening of metal, in which the definition of edge hardening would be the strengthening of an alloy resulting from the precipitation of a finely dispersed second phase from a supersaturated solid solution. Okay, what does it mean? Okay, so simply put, strengthening of an alloy resulting from a precipitation of a finely dispersed second phase from a supersaturated solid solution. Okay, edge hardening is when you'll get finely dispersed precipitation in the second phase when you are hitting a supersaturated solid solution. Okay, so to make you understand more deeper, let's see this graph. Okay, what we can learn from this graph is, okay, what does it mean by second phase? Second phase is when you are doing the second round of hitting on a metal. Okay, so let's see. Okay, basically to harden a material, what are the heat treatments we normally carry out is, first one, most famous is quenching, right? Okay, so let's look at quenching. Before we are quenching the material, we can see the microstructure of the material looks somewhat like this, right? So before heating, so normal in room temperature, before any heat treatment occurring. Okay, so in this microstructure we can see there are some empty spaces here and there, which shows that the material is not saturated. Okay, and then we are heating the material until it reaches around say 600 in this graph, no, okay, say around 780 to 750 degrees Celsius. Then what happens is, upon quenching, upon rapid cooling, we'll get a solid solution roughly which looks like this, the microstructure. Okay, what is the difference between these two? Okay, firstly, this one looks saturated, where there is no empty spaces, just like the previous one. Alright, so this is what we get when we are quenching the material. Next up, okay, let's see aging. Okay, before this, quenching, we get the material to be heated until 750 to 780 degrees Celsius, which is above its upper critical temperature. But for aging, it is not necessary to heat until that high temperature. Okay, for aging, we are heating the material only about 200 degrees Celsius, which is just fine. Why? Is because we are letting the metal dwell in that time for a longer period compared to quenching. Alright, so for instance, let's take quenching. We are giving the dwell time of 1 hour. For aging, it's around 2 hours or more. Alright, so next, after that, okay, what happens to the materials microstructure when we are doing aging on it? Okay, so if you can see this microstructure here, right, so we can get fine dispersion of precipitation within the grains. Okay, and it is said it is retained upon cooling. Alright, so when we are heating to a temperature above 200, roughly around 200, there is some precipitation forming on the microstructure. It is finally dispersed all over the grains and grain boundaries. Okay, so to keep this, slow cooling is applied. Okay, after slow cooling, the precipitates are retained on the microstructure. This is what happens in edge hardening. Simply explained, edge hardening is the second process in which you get a fine dispersion of precipitation. Clear? Alright. So now let's look at strain, aging and precipitation hardening. Okay, what is strain, aging and precipitation hardening? Okay, let me explain. Strain, aging and precipitation hardening is the definition of strain, aging and precipitation strengthening is the strengthening of an alloy resulting from the precipitation of a finely dispersed second phase from a supersaturated solid solution. Right. Okay. So let me break this down for you. Okay. Let's see. Strengthening of an alloy resulting from the precipitation of a finely dispersed second phase from a supersaturated solid solution. Okay. Does it click any bell on your minds? Right. Exactly. Strain hardening and precipitation hardening is also known as edge hardening. That's why the definition is the same. Right. Let me explain. Strain aging says that you are aging the material. Aging means, as I said before in the edge hardening, it is the second phase where you heat the material about 200 degrees Celsius for a longer period of time. Okay, let's look at precipitation strengthening. Precipitation strengthening is the strengthening of metal where you deposit some precipitations on the microstructure. So it's all similar and same process but with different names. Alright, so I hope you are getting it clear. Right, thank you. That's all from me. Have a good day.
So this is edge hardening. Yeah.
Okay. So, thanks a lot for
Welcome.
explaining. And you look familiar.
Yeah, I also thought the same. Shani!
Wow.
Yes, yeah, Shani.
Yeah.
I remember you.
It's been a long time.
Yeah.
Yeah.
So, I hope you understand.
Yeah, thanks a lot.
Alright, so I gotta go.
Okay.
See you later.
Alright.
Take care.
Okay, bye. Take care.
What you gonna do with that dessert? Do what dee da dee da dee da. Do what do da dee da do da dee da. Do what do da dee da do da da. Murder that dance floor, dance floor. Murder that.
Action.
Scene 1, take 1, action.
Scene 2, take 2, action.
Cut.
Scene 9, take 1, action. Okay guys, now let's see what's grain size reduction all about. What is grain size reduction? A process of increasing the grain boundary that acts as a barrier to slip which increase the hardness of the material. Hardness. If the hardness is increased, slip will be slow. Scene 9, take 2, action. Alright guys, now let's see what grain size reduction is all about. What is grain size reduction? A process of increasing the grain boundary that acts as a barrier to slip which increase the hardness of the movement of the material. continue பண்றா.
Scene 10, take 2, action.
Okay, now let me explain about.
Scene 11, take 1, action. Scene 12, take 1, action.
Okay, now let us look at the method to strengthen the method. There are two methods. First is dispersion. வாயில வர மாட்டேங்குது.
World goes round, life I chose. What comes next? I never really know. A million miles left to go. Them guns go pow, but I'm ready for the war. 'Cause I'll never run away from who knocking at my door. I never paid attention to whoever tell me no. I take your crown, take your down. Better stay ready, better stay ready. If the stars start falling now and the world stop turning round, oh yeah, did you give